Hi, this is Alex from devstories.eu, learning DSPy, episode 2 of 15. Making a single API call to a language model is easy, but managing multiple providers, caching responses, and tracking prompt histories usually forces you to build and maintain a custom wrapper. Configuring language models in DSPy eliminates that busy work. You might assume you need the OpenAI SDK for GPT models, the Anthropic SDK for Claude, and a separate library for local models. You do not. DSPy handles this uniformly through a single LM class powered by LiteLLM under the hood. To use a model, you instantiate a DSPy LM object and pass a string containing the provider name, a slash, and the model name. For instance, you pass OpenAI/GPT-40-mini. When you create this object, you can also pass standard parameters like temperature or max tokens. Because of the unified backend, these parameter names remain consistent regardless of which provider you actually call. You can interact with this LM object directly. Call it like a normal Python function, passing either a simple text string or a list of chat dictionaries. It processes the input and returns a list of generated strings. By default, it returns a single string in that list, but you can request multiple completions. This direct usage is straightforward, but manually passing a model object around to every function in a large codebase gets messy fast. To solve this, DSPy uses a global configuration system. You define your default language model once by calling dspy.configure, assigning your instantiated LM object as the target. Every subsequent DSPy operation automatically routes through that model. But what if you want to compare outputs between providers? Say you want to test how Claude 3.5 Sonnet handles a specific function compared to your default GPT model. Instead of overriding the global state, you use dspy.context. This creates a temporary scope. You open a Python with block using dspy.context, assign Claude as the local default, and execute your code. When the block ends, DSPy automatically reverts to your global GPT-40 mini model. That covers routing requests. What about performance? DSPy caches every model generation by default to save time and API costs. If you run the exact same prompt with the exact same parameters, it serves the cached response instantly. Here is the key insight. Sometimes you need a fresh generation without changing your prompt or adjusting the temperature. To do this, DSPy uses a parameter called rollout ID. When you pass a new rollout ID, like a unique integer, DSPy treats it as a distinct request and bypasses the cache. This forces the model to generate a new sequence, giving you control over generation diversity while keeping the core inputs static. Finally, when experimenting, you need to see exactly what went over the wire. Every LM object maintains its own interaction log. You can access the raw data through the history attribute on the model object. For a human-readable summary, you call the inspectHistory method. It prints the exact prompt sent to the provider and the exact response received. The real value of this configuration layer is that it entirely detaches your application logic from provider quirks, turning model selection and caching into simple declarative switches. Thanks for listening. Happy coding, everyone.